Well, hello everyone. It's a bit tricky to speak after Mladen and Marina. They have really terrific lectures. I hope that I will give my best to speak very well too. Well, first I want to introduce myself. I am an assistant professor and head of laboratory for systems at Faculty of Organizational Sciences, but I am also a biometric expert at Blinking, and this work was originated at Blinking actually. I will talk about how to detect spoof attacks and which methods should be or could be used for that purposes. I will cover both academic and business aspect of this problem since my background. The outline for this presentation is given on this slide. First, I will be talk about a bit problem, about the terminology, about some basic approaches for solving this problem, and data sets and performance metrics also. Further, I will speak about classification based on patterns, call distribution, image quality, some methods that are a bit old, but the professor in me should told you about the whole problem and the whole evolution of this problem. And finally, I will be talking about the deep learning era, how this problem are solved in practice. First, a bit about terminology. Fraud attack is actually any fraud, any deception when someone tries to tamper the data in order to gain some advantage. Actually, it is a really common thing in computer science, computer networks, in biometrics, image retrieval, and so on and so forth. And it can be primarily detected by expert knowledge. Later, some forensic analytic tools are developed for these purposes. Also, many statistical methods and computational intelligence and machine learning methods can be used for that purpose. Spoofing attack is a kind of sub-type of fraud attack. Actually, it is fraud done by imitation, by a trick. But when someone tries to impersonate someone else using his or her image of face or fingerprint or retina or something like that. Finally, liveness detection. That is a term usually used in biometrics. It is an ability of system to detect if a fingerprint or a palm or face is real or it is reproduced using some printing techniques, using some screen, and so on and so forth. Okay. Problem that I will be talking about is a spoof attack detection by taking photo of a face. This problem is particularly important in biometric authentication systems when we try to authenticate with face modality, and it is actually a part of a blinking solution for authentication. Also, this problem is rather big, rather hot topic, and it can be used in different areas. For example, for detecting forgery of ID or passport, any personal document. In fact, for detecting wine forgery, when someone tries to forge wine corks and so on. Okay. On this slide, you may see the most common spoof attacks. On the first image, on the left-hand side, you can see a spoof attack by printing someone's face. It is so-called print attack. The print may be flat, maybe a bit curved, but essentially this is one of the common ways one of the common tries to trick the system. The most common one is actually in the middle, when we reproduce someone's face using some electronic device, some screen, monitor, tablet, phone, TV, whatever screen. Okay. And the final and really the hardest to get attack is when someone uses rubber or silicone mask, something from Mission Impossible 1, actually. That is really hard task to detect. Okay, this is me on the big screen, yeah. how to solve this problem? Well, the most of the attacks are lazy ones. So some attacker may left some artifacts on the image, mouse pointer, start menu, some part of the application, some parts of the screen of the mobile phone, and these attacks are the easier to resolve. Also, there are cases when you are taking a photo from some screen that some curves on photo appear, so-called Mourier patterns. So we are trying to detect also that. When you are printing a photo, you certainly lose some quality of the photo. So you may observe colors, you may assess some metrics, some quality metrics of the photo, and essentially that was the main topic of my speech, will be main topic of my speech. Okay, before solutions, let's talk about problem some more. In literature, there are two subtypes of spoof attacks: 2D attacks using photo of a video or a video of an attack person, and 3D attacks when someone uses 3D mask. The mask, as I earlier said, can be a rubber or silicone, or can be a printed mask, print with holes for eyes, print with holes for mouth, print with without holes, some curved masks, 3D masks, and so on. Okay, this arose additional challenges. We have to consider different printing and display mediums. For example, it is not the same if you print something on a low-budget inkjet printer, or when using some high-end printer device. Also, certainly, it is not the same when you are using some old CTR monitor or use some high-end device with great refresh rate, with great resolution. It's much better attack, much harder to get. Also, you should consider different cameras. Various cameras have various performances, various resolution, various image qualities, and when you are trying to make something to go in production, you must cover all possibilities. And also the problem that was Marina and Mladen's also different lighting conditions, different occlusion, different face positions, some occlusion by COVID masks were also challenging for us. A little bit about detection approaches. There are two main detection approaches. Approaches based on a single shot that is based actually on a single image, and much better approaches that are more recent detection performed on a multiple images or even on a video feed. For both approaches, there is the same meta model. We should certainly do some feature extraction. Actually, we should transfer a picture into some feature vector, and we should perform some classification. In this case, the most usual solution is binary classification if you are a spoof or a real image. But there are still many questions. Which characteristics should we use? Which feature extractor should we use? Which classifier will produce best results? This problem is very actual and hot for both practitioners and researchers. On this slide, you can see some evaluation metrics that are often for this problem. Actually, since it is binary classification problem, all measures for binary classifications can be used for comparing various spoof detectors. But in literature, these three metrics are the most common: half total error rate, FAR metric, false acceptance rate, and FRR metric, false rejection rate. Actually, by optimizing the optimal solutions lay down somewhat between optimizing according to this metrics. And there are some cases, for example, when we are doing some software for a bank, when we should minimize FAR in order to make our system more safe. And there are some other cases when we are making software for gaming industry, when it is important not to stop the client, not to inhibit the client, to make some additional permeability, then we try to minimize false rejection rate. Okay, on this slide you can see some prominent data sets, now well-known data sets for face spoofing. I'm dealing with this problem since 2018, and at that point of time only the first 3 sets were available, and these sets are rather small in numbers. They are not deep in terms of different identities, and their major drawback is that are made only with 1, 2, or 3 cameras. Now there are much better data sets. The last 3 are really astonishing, and they help us a lot in developing our model. But I should say that a common problem at the most of data sets that they are highly imbalanced. So we have to add many pictures to complete the data sets. Okay, what was between deep learning times? Please prepare for time travel to 2002, when deep learning wasn't actually on site. This topic I will address is not so actual, but in order to understand problem the better, we should examine some of these methods, and we do that on graduate and undergraduate level at the Faculty of Organizational Science. I will reflect on several papers made in period from 2002 to 2018. Well, as I told you earlier, when you are taking a photo presented on a screen, Fourier patterns often occurs. So one approach is to detect those patterns. Logically, when someone talks about pattern detection on image, LBP or linear local binary patterns first show in sight. We made a hypothesis, we and much more researchers, that on spoof images there are some artifacts that may be recognized as patterns, and in general solution, this hypothesis is correct, especially when we are dealing with images, spoof images taken from monitor, from some screen or mobile phone. This approach is not so good for printed images. Kind of meta model for this approach is to use LBP for feature extraction, and then to use some classifier. Support vector machine is the most common choice for classification. There are many versions of many implementations of this model in literature and in practice. Some authors suggest to replace LBP with LBP top, to use some, let's say, uncommon parameterization of this model, to use some different pattern detection models such as Hogg histogram of gradient, and to use various classifiers. The other prominent approach is evaluation of color distributions. The first prerequisite is to change color space from RGB to LUV or YCBCR. Why? Because channels of YCBCR and LUV are much about luminance, and luminance is the key aspect when you are dealing with color space evaluation in order to detect spoof attack. As you can see on your right hand side, these histograms are made for printed attacked images, and these histograms on the left-hand side are made for genuine images, and it's clear that these histograms are quite different, and that this can be used in practice. However, we have proved that this approach is good only for detection of print attacks, and especially good when printing device is low budget one. Some researchers focuses only on L and Y channels. Some use all channels for classification. Also, there are many differences in algorithms, but major meta model is that conversion is the first step, calculation and concatenation of histograms is the second step, and some classification. For example, Costa, Souza, and Rice get the best results with the extract tree classifier for binary classification. The last approach that I will be speaking in details is approach based on image quality metrics. Actually, Galbali and Marcel suggested that they can calculate some image quality measures on macro level, on the level of whole picture, and on the micro level, on the level of pixel. And they made 18 quality metrics and tried to classify images based on them, but their results are rather unstable. Okay, there are many prominent approaches also in the period from 2008 to 2018. For example, we can combine colors with LBP, we can use some image pre-processing models, we can use various classifiers. We may try to follow skin blood flow to track if color of the face is changing during time. That is one of multi-shot approach, and so on and so forth. But we are certainly living in a time of deep learning. So deep neural networks, especially convolution neural networks, are also used for this problem in period from 2015 till now. But the first results, when the authors used DNNs, were rather bad. In fact, LBP approaches were shown better than the first DNNs, but in the last 2 years, there are many competitions dealing with the spoof attack detection. One of them is listed on this slide, and in the last 2 years, deep learning made a breakthrough in this area and is certainly a standard in practical applications, in real-world applications. Okay, the early attempts were based on transfer learning, on rather shallow architectures with several layers, and as I earlier said, LBP was producing better results. But one IEEE conference, International Joint Conference on Biometrics, made a real breakthrough. They compared and analyzed 11 algorithms. They were algorithms with both multi-shot and single-shot approaches, and they compared speed, accuracy. They compare it in every manner. Results were very promising. In fact, these 3 models should be underlined. Some pre-trained DNNs are used for feature extraction, especially ResNet50, ResNext, and some older architectures. And the results were very good, even better than novel architectures prepared for this specific problem. And I should especially underline DeepPix BIS approach. They use convolutional neural network with a focus on micro level, and on micro level they made very, very good results. And DeepPix BIS is a part of many spoof detection algorithms in practice. Also, some of them were searching for artifacts using various object detectors like YOLO for my pointers monitor, but this was rather lousy bad attacks, so it was easy to solve them. What is a future? Well, what is a present and a future? Multi-shot approaches for certain. When you are using a multi-shot approach, you are allowed to perform single-shot approach several times, and you can be more sure in your solution. Also, you may track some unwilling gestures like blinks, like trembling, swallowing, that are very often when you are taking a video of someone's face. Multiple shot approaches are divided into two parts. The one is passive approaches. The passive approaches are based on taking video without any instructions. You only follow if the observed person blinks or trembles or breathes, and you are looking for small differences between frames. On the other hand, in active approaches, the client gets a clear instruction what should he or she perform. For example, one of the action is open your mouth, but it is rather invasive action. Nobody wants to look at the phone and do this. It's not pretty, really. But there are some more subtle events, like read some text, tell me your name, move your health a bit up and down, zoom in and zoom out phone, and these approaches give the best results at the moment to us and in literature. What is future also present? Combination of multiple shot and single shot approaches. But it's rather challenging when we want to perform all of this in real time, especially when we want to do all of this on clients' phones. So that is a topic maybe for the next year, maybe for someone else that we plan to address in future. And instead of a conclusion, I just want to say that this works in practice. Well, it works well, it doesn't work perfect, there is a lot of room for improvement, but generally it works. Yay. Thank you.
Okay, we have a question there.
Hi, interesting techniques, Muthu Ramachandran. I'm just wondering, people are very clever, maybe I'm not aware of, they download your picture. It happened to one of my friend, Facebook, and he created on his name. Perfect, nobody noticed, and they thought, oh, you send a friend request, and I received that, oh, he looks my friend. So how do we deal with that, Pavle?
Could you repeat the question
again?
I'm not certain that
you
I
are saying
it.
You are saying replicating the photo picture through different means. I'm saying they don't need to do it. They can download your picture on Facebook, WhatsApp, and they're creating on your ID. So how do we deal with that?
Well, there are some analytical tools for that. They try to inspect the header of the picture, the device that was picture made, and so on and so forth. But in Blinking, we have our web app, and we are taking only pictures using that web app. So in fact, that was not our problem in this case.
I think we have another question there in the last row.
How do you deal with deepfakes?
Okay, great question. Deepfakes are present, really, but it isn't our problem, again, because when you do deepfake, you again must take that photo from a screen or print it or make a mask according to it. So actually it is a way to make some photo, but it's not our problem because it is under these cases that we solve.
Where is it mostly used? Face spoofing.
When someone else tried to be authenticated as someone, in our cases, when minors don't have a license, don't have an ID card, so they act as their parents, for example. And there are some cases in our bank applications when someone tries to make money withdraw using some fake identity.
So basically, it is in the offline world.
Yes.
Not
yes.
not online.
Our app is online, so they are trying to do that online, but really offline world.
Okay. Any more questions? Another, yeah.
Okay, you said this works, so I'm interested which one of all those mentioned approaches works and which one is the best in your experience.
Okay. I made this presentation more as a presentation at faculty than presentation of some business solution, because I really can't share much details about our solution, but multiple shots with action and single shot in several frames. I can talk how we choose that frames, so a combination of them.
I think I don't see any more hands raised. So Pavle, thank you for this presentation. Pavle Milošević.